Why there is a laboratory here in Amsoil? I think that only is to produce, mix, and put in a bottle. But I think that is something more specific, right? This is where all begins, right?
Yes, it all begins over in this part of our lab where we do all of our prototype blending. So we have all of our raw materials that might be stored in large tanks.
When you see raw materials, you mean the base and additives?
The base oils and the additives, all the different components that we want to use to build up our formulas. We have them all available in our lab so that we can quickly make small scale blends, so we can start testing out the ideas, balancing out different components so that we can get them into the tests in our rest of our lab.
Okay. Estoy en una zona de las instalaciones de Amsoil que te voy a mostrar, que para mí es de las zonas más fascinantes, porque mira, como puedes ver aquí atrás, estoy en el laboratorio, ¿sabes? Tú que sigues estos videos, pues bueno, sabes que la parte química es para mí muy importante, así es que vamos a entrar, vamos a ver a quién conocemos que nos puede explicar por qué existe un laboratorio dentro de las instalaciones de Amsoil. Acompáñame. Vamos a ver a quién encontramos. Pues obviamente aquí están todos estos equipos que ya nos explicarán qué es lo que hacen, por qué se tienen todo esto aquí. Es súper interesante, la verdad. Yo sé que a ti te gusta mucho la química y vamos a buscar a la persona indicada que nos va a decir qué se hace aquí adentro. Aquí está trabajando Elise, entonces vamos a hacerle unas cuantas preguntas. Hi Elise, morning.
Hello, good morning.
Can you spare some time with us to explain why there is a laboratory here in Amsoil? I think that only is to produce, mix, and put in a bottle. But I think that is something more specific, right? Elise, thank a lot for this time.
Yes.
Please share with us, with the people from Latin America, the reason why there is a laboratory here in Amsoil.
Yes, there's lots of reasons that we have a lab at Amsoil. So the group here is very core in research and development.
Okay.
So we are looking at the latest and the greatest of what we can provide to our customers in terms of formulations for their applications. So it all starts here. We're kind of the knowledge hub of Amsoil. We have all the different ideas on how we can build up formulas to meet new vehicle specs or other applications that might be emerging. So for example, hybrid engine oil, high mileage, we launched those last year. Those really started in this lab on paper, thinking of ways we could build up formulas that would speak to those applications.
Okay, so when we talk about engine oils, that means that there is no recipes in the industry. Amsoil creates its own recipes for engine oils. You test. We visit before an area with some dynos and vehicles. So the products, you design the products here, send to that area, they test and go back, something like that?
Something like that. We also work with external partners to help ensure we get into the right applications for that validation. So we have some capabilities in-house, others that where we have to utilize, say, taxi cab fleets in Vegas or other types of applications to get more vehicles on test to really get those results faster. So some is in-house, some is with other.
Okay, so can you show us what is inside of this lab?
Yes.
Okay, thanks.
Yes.
Well, feel free.
Yes.
Where all begins?
Where it all begins.
I think that there is a flow inside this lab.
There is a flow, for sure.
This is where all begins, right?
Yes, it all begins over in this part of our lab where we do all of our prototype blending. So we have all of our raw materials that might be stored in large tanks.
When you see raw materials, you mean the base and additives?
The base oils and the additives, all the different components that we want to use to build up our formulas. We have them all available in our lab so that we can quickly make small scale blends, so we can start testing out the ideas, balancing out different components so that we can get them into the tests in our rest of our lab.
Okay, so in this area you mix that
we mix things
raw
up
materials.
Here, yes. We might dial in some of the first viscometrics, so the viscosity, make sure that all of those components have been mixed in the right ratios, so that when we give you a 5W30, it's a 5W30 and not some other viscosity because of an imbalanced component. So we get things dialed in here, make sure they hit that first requirements of viscosity, and then we bring it to the rest of the lab for additional performance testing.
Okay, let's go. When you design a 5W30, according to the SAE 300, etc., I remember, maybe this is personal, maybe this is not going to be there, but if I remember, it's from 9.5 to 12.5, the viscosity at 100 degrees. What is the reason you put in the lower sides of the scale? I mean, in 10.0, 11.0, or not so close to 12. Do you know what I mean? No.
Why people build in certain areas of viscosity, or
Yeah, because we test some products and we found that some product the value is 11.1.
Okay.
Why in the top and not in the bottom? Is there a reason why to do that?
Yes, so we are all about engine protection. So oftentimes viscosity is going to bring you that film thickness that protects your engine or the systems you're lubricating. And so we tend to build at the higher end of viscosity to ensure that you have that level of viscosity protection.
Do you think it's better, talking about a 30, do you know, a viscosity 30, 5W30, for you as a specialist, is better thicker or thinner? Inside that parameters, 9.5 to 12.5, what do you think is better for the engine? Or to be in the middle?
It's making sure you design it to the right intention of the application. So if you're going for a more fuel economy product, you may be hitting more in that midline viscosity for that viscosity range.
Yeah.
Because ultimately too, you want to make sure you maintain that viscosity throughout the life of the product. So for the time it's in your system, you want to make sure that that viscosity is maintained as well. So there is some design that goes
is
into
to be
that.
there. Okay, I understand. So there is no a good one and a bad one. It depends about the application.
Yep, it depends on how you've designed it.
Okay, perfect. Let's continue with the tour. So
Yes.
in this area we can see a lot of, I don't know how to say, machines, or I don't know the name of that, but
Yes.
what happens here?
We have a lot of different machines, equipment in our lab. They can test a variety of attributes of a finished, well, I shouldn't say that. They can do both testing on the raw materials, the base oils or the components, and then we can also apply these same tests to the finished goods. So that allows us to apply tests to look at the best components to put into a finished fluid, as well as see the overall performance of the product.
Okay.
So for example, oxidation is something that is of interest in
Yeah,
a finished
good.
product, but also can vary within some of the different components you might use within your formula. So base oils, for instance, they can have different oxidative tendencies.
Yeah.
We use pressure differential scanning calorimetry, big word there, PDC.
Yeah.
That's right here. It's a test that allows us to oxidize material
Yeah.
in a fairly quick screening process. So we can look to see which types of formulations, which types of base oils have the best oxidative profiles, so that we can leverage them in different ways in our formula. So this is one test that we use.
This is what that machine does.
Yep, that's what that machine does. It helps us quickly look at oxidation so that we can pick out the best components for our formulas, as well as look at different formulation designs to see which can perform the best too.
Okay.
So that'd be like a screening test we would use in development.
Okay, I understand. Okay, perfect.
We also have some other test capabilities that look at the impact of air in a lubricant. So air is a bad lubricant.
Air as a bubbles?
Air as in, yes, entrained air, bubbles.
Okay.
Foam.
Foam,
Being
yeah.
one. So this would be a test that allows us to look at foaming characteristics of oil. So kind of how they handle that aspect. It's important for industrial fluids, engine oils.
I remember an additive that broke bubbles, right? I remember something like that.
Over in this corner, we have testing capabilities that look at low temperature viscosity. So this would be Brookfield viscosity testing.
Okay, when you say low temperature, it's very low.
It's very low, and it can go even lower than that. It can go down to negative 40 centigrade.
40 centimeters.
Or further.
Okay, for an area like here in the loop, it's interesting. For me, to be cold is -5, not less. But it's good to know that the engine oils that you develop can guarantee the lubrication even in that level of cold.
Yes.
Okay.
We look at very cold to very high temperatures because that's where we're building in our performance.
Okay.
Along this back wall, we have a lot of different, you see ovens, refrigerators. So we work on formulation design is key. We work a lot to ensure we have good formulas, but we also have to make sure the customer gets the formulas in their bottles.
Okay.
So package testing is also something we do in our lab. So compatibility with the packaging that the consumer ultimately gets. We make sure that the fuel additives or the oil and the packaging we use all gets together nicely.
Okay.
To ensure that a quality formula makes it to your door as the customer. So that goes on. We take the finished formulations, we put them into their different packaging, and we'll actually do different tests at high temperatures and low temperatures to make sure nothing happens to cause leaks.
Okay.
Or other incompatibilities, paneling that could occur to make your bottles not look
Yeah, and change the formula
Yes.
because the bottle.
potentially, yes.
Okay.
So we do all of that in the back of this lab here. Over this way, we get into some of the other analytical techniques we have.
Okay.
So this is our NOAC volatility tester.
Okay.
So that helps us understand the performance of engine oils with respect to their volatility. So we heat it up to high temperatures. It allows the oil to volatilize, and you can measure the different performance levels, typically driven by different base oil chemistries that have different volatility characteristics.
Okay. Okay.
We do
Yeah.
TAN and TBN testing, so total acid number and total base number.
Yeah.
So these can help us understand the chemistries of different formulations and how they're performing, how your total base number is managing itself throughout oil performance in an application. So we'll oftentimes monitor TBN as we're testing oils down in our dyno, just so we can understand the severity of the application and the performance of the oil.
In Latin America, we have some not so good quality fuels. Maybe the quantity of sulfur is very high. I have the theory that because of the quality of the fuel, well, the TBN gets lower even faster. Do you think it is related?
It would make sense. I would say the combustion characteristics of your system is going to impact your TBN, since that is there to help offset the acidity from that combustion process. So
Yeah, maybe that's the reason why an engine oil can last more in some country than in other. It's not because of the formula. It's not a different formula. Let me try to explain. Well, the formula for the US citizens is one, but for Latin America is different. That's not the idea. It's because of the fuel, the quality of the fuel.
Yeah.
Make sense for
yes,
you?
no, I can. Interesting perspective. I haven't heard that before, but it does make sense.
But it makes sense, yeah, because even some other products that we test in our channel from Europe, the results are very different. The test that they made in Europe and the test that we made in Latin America. And the reason for me is the quality of the fuel. And with this test, well, maybe you can be sure that your products meet your standards, but you don't know how the products will perform in some other areas with some different fuels, unfortunately. But the time that it lasts, it will be the best performance that we can get, right? Okay, perfect. Interesting. I like too much the TBN and the TAN test. So please tell to us, what about this machine? What does it do? I can read liquid particle counter. I don't know what's that.
You're an expert. So it's a liquid particle counter.
Yeah, it sounds
so-
like that.
So we have different quality requirements on some of our products. This would be a tool that we can use to actually look at the particle count, the ISO particle count of a finished fluid.
Okay.
So we do a lot within our production to keep things very filtered and very clean. Some of our products even have quality specs, QC specifications that require very, very, very clean lubricants to be produced. And so we have a particle counter to support that.
Okay, I have seen some analysis that can show us some particles, parts per million, but aluminum, but that's different.
That would be the ICP.
Okay.
Yes.
Is this machine?
Yes.
Okay.
So particles can range in different sizes.
Yeah.
You have small particles, large particles. So the particle counter helps you understand the sizes of those particles. So there's different micron levels that it reports at from a cleanliness
When I
perspective.
see a report of ppm,
Yes.
what size of particles
So
is that?
typically for ICP OES, it's based on the nebulization of particles that then gets excited, and you can see kind of the optical emissions of those different key elements.
Okay.
To be able to even get to that state and be detected, you have to be about 5 microns or smaller. So ICP only lets you see very, very small particles.
5 microns or smaller?
Or smaller, yes.
Okay.
Very small particles are capable of getting into basically the analysis system so that you can analyze it. It doesn't let you see some of those larger particles that could be produced in wear.
Okay. Yeah, I saw recently. I discovered a test that show you something like magnetic field, and you can locate even. For example, if a gear lose one teeth, it's so big. You know, you can you can show it with this analysis. But that teeth is made of iron, maybe, and you can see as with a magnetic field
Yes.
that there is something huge,
Yes.
huge talking about analysis. So it's very interesting to
Talking
see.
about analytical ferrography.
Yeah, something like that. Yeah.
Yes, also very helpful in used oil analysis.
Absolutely. Okay, perfect. Oh, let's continue.
Alrighty.
Sorry, that takes my attention.
Yes.
4 balls, something like that.
Yes.
Yeah.
So that is our EP 4-ball machines with extreme pressure wear testing.
Okay. Yeah, yeah, and then you can see the wear that
Yes.
get
Yes.
the material.
For EP 4-ball, you can look at the seizure and the welding that can occur within extreme pressure
Yeah.
scenarios. We also have the 4-ball wear test in this lab, which helps you look at more of that wear scar, the boundary, lubrication driven wear.
Okay, I like that
So
machine.
very capable in wear testing. We're also able to run shear testing on this system as well. So
Okay.
when you build up different formulations, you may bring in different types of viscosity modifiers, performance polymers to help build out viscosity for certain applications. Not all VMs are created equal. Some are very susceptible to shear, and so we're able to look at different formulas, competitive formulas on the shear tester as well.
Okay. A big issue when you use an engine oil is how it affects the fuel dilution. You know, in the combustion, a little amount of fuel go down through the ring to the segments to the rings, and it broke the engine oil. Do you have any machine that can measure the fuel dilution?
Yes, we can look at fuel dilution using our gas chromatograph.
Okay.
So our GC, it allows us to measure quantities of fuel that are dilute in the lubricant.
Okay. So this machine shows you in percentage, right? The
In
result.
percentage, yes.
In
You will get a percent fuel in the oil, and so we can analyze many different types of oils, different types of fuels. It's
Okay.
a very standard test that's run.
What is the maximum level that it's allowed to reach in engine oil? I mean, 1%, 2%, it's okay, 3%.
It probably varies by design.
Yeah.
There are applications out there that have certain dilution challenges that oftentimes they'll recommend a higher level of viscosity in their owner's manual to help combat the dilution issue.
Okay.
So there's different ways fuel dilution has been managed more on the application side. So it's hard to say what would be
Yeah,
appropriate because it can be managed differently to ensure that that resulting viscosity is what the application needs.
Okay, I understand that. If your viscosity is okay, the dilution, it's okay. But if your viscosity is going down, that's too much fuel dilution. Maybe that's a way to try to understand what happens in my engine, for example, right? Because I try to read, but you are the expert, and it's a very good answer.
Ideally, your oil would manage all of your viscosity needs and you wouldn't have to account for fuel dilution, but there are certain designs that are more inherently challenged by fuel dilution, just depending on equipment manufacturers.
Okay, perfect. Thanks.
Yeah,
Another machine, or?
And then we'll take a walk this way. We get into our quality control testing. So we have an area very dedicated to supporting our plants, which is right outside the door.
Okay.
So one of the key tests we do for quality control is viscosity. So we measure
Okay.
viscosity at 100 degrees C and 40 degrees C for a lot of our
Okay.
products. So we support that. We have an automated viscometer that can help us process samples.
Okay.
We also utilize viscosity baths as well.
Okay. That is at 100
100
degrees.
degrees C and
C.
40 degrees C.
Okay.
So we have a variety of tools. Over here we have our cold crank simulator. So this is another low temperature test that can be used.
And what do you measure? The
This is another measurement of viscosity.
Is viscosity.
Yes,
Okay.
at low temperatures. It's a little bit different than the Brookfield test. This is what gives you your W rating on an engine oil, is the
Okay.
cold crank test.
And the cold cranking, how cold is the cranking?
It can go down to negative 20,
Okay.
negative
Cs?
25 C, negative
Okay.
30 C, depending on the requirement. So we can hit a lot of different temperatures with this test.
Okay. As a user of Amsoil engine oil, can I check that value in the safety data sheet or in the is there that because some information that you share with us, I remember that I can see that information in the technical data sheet.
Yes, a lot of information's in the technical
Is
data
there,
sheet.
right? So
Even more available if through technical support as questions arise.
Okay, so we can trust in that information after see all these machines your
Yes.
knowledge. I think that we can see what that information says, right?
Yes, yes, all very real numbers.
Very real numbers. yeah, because you always need to trust in somebody. At this moment, we can put a face behind that numbers, and that's you.
Yes.
Thank you very much for the visit. I really appreciate
Yes,
that
you're
Amsoil
welcome.
received to us and your time for this.
Great. You're
Thank you.
welcome.
Thank you.